All right, let's go ahead and get started. Hello, everyone, and welcome to the +DS Introduction to Data Science and Healthcare Session 1. My name is Matt. I'm an associate professor here at Duke, and I will be your instructor for the course today. I'm also joined by two TAs, Ali and Akshay, who just said hello over on the chat board. They'll be manning those chat boards, and so you can ask questions, and they'll be able to help and chime in. I'll also mention that a lot of the content that we'll be covering today, they generated. So I'm just here to deliver it to you. I started teaching a data science course about a year ago called Tidybiology. The name was inspired by a series of packages that we'll introduce you to today called the tidyverse. And this is really, I started this with an intention to try to bring data science to molecular biologists and young graduate students. Today we're expanding that course, and we've generated a lot of new content just for you with a focus on data science and several of these tools and learning how they are applied to healthcare and healthcare decision making. So before we dive in, I have a couple of housekeeping sort of points to go over with you. So first, clearly, obviously, the social distancing means that Tidybiology needs to be delivered to you today. We're streaming live from Durham, and that means that we can't be there in person to help you. However, like I said, we've got two fantastic teaching assistants, and they'll be able to help answer questions along the way. I also have introduced several opportunities and exercises along the way that we will be able to have intentional pauses where you can ask some questions. We'll take those questions. We can then bring them to everyone and really have opportunities to pause, to take a break, and to assess sort of what we know. So again, feel free to use those chat boards. I already see several people are saying hello, checking in, and I like to see that. Second, I'm also taking this opportunity to change some of the course delivery methods to really try to develop these interactive slides. And so rather than me standing in front of a room, let's say with a whiteboard or with a presentation, I've developed these slides now so that you can code along with these slides. And so we'll have a slide, and the slide then we'll have a box below it. We'll introduce you to that, where you can type in the code and basically code along directly in the slides as we're working. So I'll introduce that in just a moment. So that actually brings me to my final housekeeping point, is just a few things about infrastructure. And so we've decided to use a fantastic resource that RStudio has developed called RStudio Cloud. And RStudio Cloud is a cloud-based environment that allows anyone access to RStudio's integrated developer environment. Again, we're going to get over what some of these terms mean. But essentially what that means for you is I have preloaded all of the packages and all of the course material into RStudio Cloud to make it easy for you all to essentially follow along. So I sent out an email, a couple of emails earlier this week, and in those emails were instructions to sign up for an RStudio account and how to access RStudio Cloud. So if you have not done that yet, and you don't know how to do that, then go ahead and please ask Ali and Akshay in the chat boards for instructions on how to do this. Essentially, let me just switch over here. What we can do, what you can see here is this is RStudio Cloud's environment, and you should be invited to a space over on the left-hand side that is called Tidybiology-2020. Again, this is sort of the name of the course and the sort of teaching that we've done previously. And so within this Tidybiology environment, you should see a single project, and this project is called +DS. Again, this offering here is in collaboration with the +DS in-person learning experiences. And so on that project, if you just go ahead and click on the +DS, what will happen is it will open the project, but importantly, it will make a copy of that project just for you. So you don't have to worry about breaking something, or you don't have to worry about, oh no, I might mess up some of the slides or something like this. You should go ahead and click on that copy. That will then save a version for you. And what you can see here now is an environment that we will spend a lot of time working within over today and tomorrow. And this is the developer environment. What you can see is, I'll give you an introduction or a tour of this in a little bit, but what you can see here is a few panels. The lower right-hand side panel down here, make sure that you're on Files, and Files should have all of the files that we're going to use for the course today. Now, some of you were quite eager and excited to basically take this +DS project and make it your own. So that's fantastic. but we've made some updates. In fact, one of the things that I just added are some slides. So if you want a PDF of the slides, then what you can do is you can look in this project directory. And so here in the folder slides, you can see there's session 1 and session 2. You might not have these yet, which means it's very simple. In the upper box, I want everyone to do this now. In the upper box, what we can do is we can look here, and there's a tab called Git. Don't worry what's down here. There's an arrow that points down. The down arrow, I just want you to click that, and that's going to be a pull command, and that's going to make sure all of your materials are up to date. Okay, so if you do that, then you should make sure you have all of the materials, including the slides, and you should be ready for class today. So the second thing is that sometimes what you'll see is that RStudio gets disconnected. We can just reconnect, that's fine. There's a lot of people trying to access this, infrastructure right now. That's not a problem. We should be able to have everybody access everything that they need. And so you can see we're up to now 70 derived projects. That's good. People now are taking this and making a copy of it on their own. The second thing is you might not yet have installed all of the packages. What we've done, and I'll explain what packages are later and exactly how they work, but what we've done now for everybody who's making their own project is installing all of these packages for you. And so what you hopefully will be able to do is when you start this project, RStudio will oftentimes tell you you don't have these packages installed. It's quite clever that way. And we'll ask you, do you want to install these packages? Just click yes anytime that you see that. I also here in the code directory in miscellaneous, I also have all of the packages that you want to install. Again, I'm throwing a little bit more at you than I would like right now because there are some infrastructure things that we have to do in order to get set up for class today. But if you are familiar with R and you want to install the packages, all of the packages are listed in this text file. Okay, so then one last thing. I will be presenting mostly in this format for you today. So what you can see is that the slide is on the left and my sort of speaking head is over there on the right. I'm going to be presenting slides, and I made these slides available for you, but again, these are interactive slides. So what that means is that you will be able to execute what is happening in the slides as we go. So if you go ahead and then look for in the code directory, then what you will find +ds session1.rmd. That's the file that you want. If you click on that file, this opens up then the interactive slides. But what you have to do is you have to run the document. Don't click on that quite yet, because I want to show you something in this down arrow here. This down arrow has two options. One is to clear knitter cache and clear pre-rendered output. So what happens is you'll be moving back and forth between the our markdown documents that we have and the slides back and forth. What happens is if the slides ever give you a problem, you're going to need to just click here on this clear pre-rendered output. That's going to basically reset all of the slides, and then you'll be able to see them. So again, just a couple of things. But if you click Run Document here, what you should be able to do, I have a pop-up blocker installed, so it's going to say, I have a pop-up blocker. If we try again, and now we have these slides that I'll be able to walk through with you today. So what I would recommend is positioning the video, the YouTube channel, maybe to one side of your monitor, and then the RStudio Cloud environment to the other side. And this will then allow us to allow you to see what I'm showing you, but then also code right along. So the last thing that I'll just mention before we dive in is that this is, again, just the environment that, that we've set up for you. Everything is here. If you have some specific questions about installing it locally, if you have specific questions about how to access for your specific purpose, you could go ahead and see the Ali and Akshay on the chat boards. They'll try to help you. But really what I would encourage is everybody to come along on this RStudio Cloud journey with us today. And with that, we are going to get started with an introduction to biological data science in R. So the first thing that I want to start out with is big picture sort of context. And this thinking about decision makings. And there's a historical perspective, which I think is interesting to mention here, which is that doctors make decisions based on symptoms. So there's a collection of symptoms, whether it's a single patient or a collection of patients, and doctors make these decisions based on these symptoms, and this is how it's been essentially for the entire history of medicine. But it's interesting because something is happening now in healthcare, which is that this digital healthcare era introduces new challenges to decision making. One of the obvious ones is volume. The data collection and storage allows access to huge amounts of medical information. The second is ubiquity. Data are everywhere. They're accessible across geography, across social status, economic classes, and so on. And also, there's a important element of latency, which is the speed with which we now have access to healthcare information is faster than ever before. And so these different elements add a complexity and a challenge to decision-making in healthcare, which then leads to a very a simple question is, how do you make better healthcare decisions? And that's the question that will be driving the entire purpose and the entire reason that you are joining me here today, is because whether you want to make decisions for healthcare, whether you're coming at this from a perspective of a student who wants to make a decision about a project, whether you're coming at this through some financial analysis, these tools in data science really facilitate better healthcare decision making. And so this concept is really called now data-driven decision making. And so we go now from this world where we have hunches and we talk to experts, and the experts then have seen this maybe before or have a hunch about something, but really no, there's more and more decision making is really being driven by the data. And this is really a simple schematic of this knowledge pyramid, as they call it, where data then is assimilated into information. That information then can be generated into knowledge, which then eventually gets converted to wisdom. And so really we're at the base level of saying, okay, how do we take data and turn that into information? And again, with a particular focus for this class today on healthcare data and how we turn that healthcare data into healthcare related information. Well, the way that we do that is this emerging field of data science. So now you've probably heard about data science before. You've probably heard about several different types of data science and what it's used for, and it's a buzzword. And if you're some computer scientist, well, really you should be a data scientist because then you're going to make 2 times as much money, and so on. But really, it's interesting because the field of data science is sort of this new idea, this new term, and it really encompasses several different types of activities. So one activity is this, we'll start on the right-hand side here on this green part, where it's math and statistics knowledge. So certainly we need some knowledge of math and statistics to be able to do data science. Well, there's also this element on the left where they call it hacking skills, where they're taking several different hacking, not really computer hacking, but hacking together different types of code in different ways to try to facilitate some information generation. And this is interesting because there's no universal language for data science. Data science is done in a lot of different computer languages. It's done across a lot of different sectors. And really the idea is to put together different pieces that allow you to, again, go from that data into information. And then the bottom part here, I think is among the most important, which is substantive expertise. And people clearly recognize that data scientists need to have some expertise where they are sort of wielding this newfound power, because you can have, let's say, hacking skills or math or statistics knowledge and not really have the expertise and not really quite be able to ask the right question or glean from the data the right answer. And so it's interesting. This is now a dated slide. This is one of the first ideas or terms of data science and describing data science. And this has since been updated. This is one of my favorite updates. This is the Venn diagram of data science 2.0. So we've got still our math and statistics knowledge. We still have our hacking skills and our expertise, but then also this sort of Joel Gruss put in a clever sort of evil components. And you can have a chuckle at the different Venn diagram elements where we have essentially the outside committee member, thesis advisor, and so on. Anyhow, the thinking is that the data science is really this emerging field that allows people to use skills, use tools that then allow people to glean information and convert that, or data, and convert that into information. So again, this overall goal here is knowledge generation from the data and this data-driven decision making. Okay, so how do we do this? Well, like I told you, there's several approaches to knowledge generation. New tools allow data interrogation more easily than ever before. In fact, this is one of the beautiful things. I'm standing here today sharing some of these tools with you because they are intuitive, because they are better than they've ever been, because they are more accessible. And that's really one of the most exciting and most remarkable things. So this is interesting. This is a site on Stack Overflow, which we'll talk about a little bit, that essentially has different programming languages. And so this is a summary starting in 2008, 2009, inferring the most popular programming languages and the changing the popularity over time based on the number of questions that are being asked about them. And so you can see this is quite dramatic. We could call this like a horse race where we've got, you know, C# up here, and PHP's coming in, and JavaScript, no JavaScript coming up, and so on, C++ and Python. Python will take a few more years to become much more popular and so on. But it's actually interesting because we could watch this all the way to the end. The music, I can guarantee it gets much more dramatic. But the point, though, is that when we look at the world's most popular programming languages, still the number of worldwide Excel users, and this is just estimated, but the number of estimated worldwide Excel users is far, far more than any of these programming languages. So it's interesting because really we've got this wide range of expertise. We've got people who can program in Excel, people who can open up an Excel spreadsheet, all the way down to people who are highly experienced computer programmers. But really what we want to do is we want to take all of this and bring it together and take what we know from the tools, what we can learn from these new tools, and try to come up with strategies to do data science better. So that's the end of my sort of introduction, sort of why we're here, what we're going after. Really this question that is driving us is how can we make better healthcare decisions? And I'd take a second now and just turn to the chat boards and make sure there's no burning questions. It looks like Akshay and Ali are helping some people get set up, making sure that that everyone's on board. We're about to transition. Again, if you don't have access to the slides yet, you can just follow along here. Hopefully Ali and Akshay are helping you guys along. So if there's no other general questions, again, these mostly look like technical questions, then we'll go ahead and get started with this idea about the R programming language. So I'm going to be teaching you about data science today, and all of the data science that we're going to be doing is in a programming language called R. All right, now, R is a language. R is a computer programming language, and the way that you should think about it is it's a foreign language, just like Spanish or French or Mandarin. It has its own syntax, it has its own rules, and when you start thinking of it like a language, then really, like any foreign language that you need to learn, you will have to learn the syntax, you will have to learn the grammar, you will have to be reminded constantly. So I want to start with this because with this perspective, then we can say, okay, today our goal, my goal for you, is to try to introduce to you a new language, and that language is called R. All right, now, first, so the first thing to notice or to know about this is R has values. So within R, you have a value, and this value can be a number. In this case, it's 1. It can be a word. In this case, it's North Carolina, or it can even be a date. And all of these are called values, and this is sort of the core unit of this language. All right, essentially, these would be like words. R also has objects. An object is something a little bit different than a value. The object is something that has that stores a value. So we assign this using this left-hand arrow, and it's a name without quotes. So if we go back one slide, you can see that this name has quotes around it. This name has quotes around it. One of the key and important distinctions here about an object is that it does not have quotes. All right, so this object can be a value, it can be another object, it can be a function, it can even be a result of a function. All right, so this is the very first time for you guys. If you have the slides open, then the thing I want you to try here is to assign an object. So remember, there's no quotes on its name. So here, I call my object name. You can call it whatever you would like. And then get comfortable with this left-handed arrow. And this is then going to be the way that we assign this object. So we're assigning name, a number, and the number that we're assigning is 4. And then, so we can do that, and it looks like this. Name is 4. And if we run this, then we have an object stored in there. But that doesn't really tell us too much. What we want to do is we want to then say, okay, what does name look like? And if we run this, then what we can see is that name has a value and name is 4. All right, so go ahead and try a couple of times. You can then start over. We could assign a different value. I could say, this is 15. And then again, what I can do is I can say, okay, my value is Matt, and I can run this, and Matt is 15. So again, just this idea, we can store a lot of different things. I can then also say my value Matt is going to be this special word, Matt. And if we run this, then we should also be able to then pull this back out. Or if we go like this again, we can come here, and we can then call name, and name then is Matt. So there's a couple of different ways you can do this, but go ahead, try, and just assign a couple of objects. This is something that you will do so often. It's one of the fundamental things in R here is we need objects, and objects store things for us. We will throw away objects, we will generate objects all the time. So what we need to do is get familiar with this idea that we have objects. Okay, now R also has functions. So a function is important. A function, this is actually the beauty of the R programming language, is it's a functional programming language. The way that we write a function is also a name without quotes, but this is followed by a parentheses, and this tells R that this is a function rather than an object. The functions have optional arguments, and so here is a simple function. This is round. If we guess what round does, this digits equals 3. This might be a simple or clue to give it away. But in this case, round is going to round x, and in this case, I just put in a simple example. R knows what pi is, and so if we run this, we can see that that round is going to round pi to a certain number of digits. Okay, so we can also then put in again. So x, and let's say it's 1.234567889, and then what we can do is we can round x, let's say, to 1 digit, and we can run this, and it's the same idea. So x is my object, round is the function. The function is going to act on an object in this case, and what we see is that we have this. This is called a function argument. This is I think this also has a default. Sometimes if you don't put this in, the default is 1 in this case, so it will round to 1 digit. And so what you can do is, again, try. So this is our very first function. It's round. It's going to round our number. In this case, it's going to round pi. Or if you want to assign an object a value, let's say x, you can put in x and so on. So go ahead, and the idea is just to try to play with this, to get familiar with these ideas. And again, this parentheses after tells R that this is a function. Okay, so this is our first quiz. So again, hopefully following along, you got the slides open, so you can go ahead and try. So which one of these are numbers? So if we then look here, we would say, I'll give you guys just a second. Go ahead and try it. All right, so let's try this one. Incorrect. So this is not. So this has quotes. So this is a string. We can try again. This is a string. This would be an object. So this is the only one that would be correct. So this is a number. So again, string, object, string, number. Okay. Now let's look here. suppose we assign the number 1 to an object ONE. All right, so which of these will work? You can select the ones. If you'd like to then play down here in this code chunk, you can go ahead and try it. Like if we go here and say 1 is 1, just like we assigned it here, we come down to this code chunk. That's what we call these code spaces. These are code chunks. What we should be able to do is if we say, log of 1, let's see if that works. We run that, and we are able to see that this is 0, so that works. If we go like this, we then run this one also, we can see that this also works. I should probably start over to clear that output. So log 1, right? So if we take a log of a number, that's also 0. So we should be able to do this one, and we should be able to do this one, and that's correct. Again, we can't perform a numeric operation on something that's not a number, and so that's why these other two don't work. So, all right. Now, one of the important things is that data in R are stored in tables, which are also called data frames. And the data in a data frame is conceptually equivalent to a spreadsheet. So anybody that's looked at a spreadsheet should be able to look at something like this and see it's quite familiar. So we've got one column that has a patient ID. We've got a column of age, sex, and a few other variables, and so on. Well, this looks like a spreadsheet. This is exactly the same, just a different output of the data that I just showed you. But this is a special kind of data frame called a tibble, which is one way that it's a special data frame within the R programming environment. But if you look, on one hand, this looks like a little unfamiliar. It's got all of these like pound signs, and it says tibble, and it's got some other sorts of crazy notation down here. But what we can see is if we look closely, that we've got a patient ID, we've got age, we've got sex, we've got a couple of other variables. And so this looks just like here. It's just a slightly different format, but it's exactly the same. And so when we are going to be talking about data within R, these data are going to be in data frames or in tibbles. And what you can think is spreadsheets. It's going to have rows, it's going to have columns. Now the slight difference is a spreadsheet is incredibly flexible, that can store a lot of different types of information, different types of information all within like one row or one column and so on. There will be some restrictions to the types of data and how you can store things in a tibble, but we won't get into those details right now. What I want you to really remember at this point is that data are stored in tables and data frames, and those are conceptually equivalent to spreadsheets. Okay, now these spreadsheets are available to us. I'll be showing you one of the ones that we'll be using for much of this course today. The interesting and important thing is that you can pull separate elements out of spreadsheets. So we've got this entire, let's say an object, and the object is a data frame. Well, importantly, we can pull specific columns or rows out of the data frame and use it. So we've got this larger object, and we can make another object out of it. So one thing that we can do is, here's an example where we can call a single part of the data frame. So in this case, our data frame is heart. And what we can do is we can pull out this target variable. And this target variable, it can tell us that we've got one column. We've got just over 1,000 rows. And it looks like that this is a number that is between 0, it's either 0 or 1. Okay, so the way that we call part of, or in this case, it's a single column within the data frame, is by using this little $sign. So here's the data frame name. Here is what we call the variable name. And we use this little $sign to interact between the, to get this out. Okay, let's see. All right, so I see that Matt's going a little bit fast. All right, slowing down. All right, so we've got data frames. We've got, which is a special type of object. We can then extract some information out of that, that data frame. Okay, so we can try that here. So again, this is your code chunk. This is for you to play. So if we type in heart, so you guys can follow along, target, and then we run. And what we can see is we pull out a single column. This is a variable, and we just list this out, and it's a bunch of zeros and ones. There's a lot of other types, actually, of data in here. I showed you before when we had that schematic of the data frame that looks like the Excel sheet. Sex was one of the columns, so we can see this is male, female, and so on. So this is, again, just go ahead and practice. You can pull out heart patient ID, and what you should see is 1, 2, 3, 4, 5, 6, 7, and so on. So these are patient IDs that we sort of assigned for some exercises later on. But go ahead and try a couple of these. Again, just you type in heart, the $, the variable that you want to extract, and then type it into this code chunk. And then over on the right-hand side, you can hit the play button, run the code, and try it below. All right. So I told you that you can also take some of these elements of the data frame or these columns within the data frame, and you can save them as an object. I told you the good thing about objects is we make them, we can throw them away, we can manipulate them, and so on. So the way that we assign an object is from a data frame is exactly the same way that we assign an object when we use that simple example of assigning an object called name or assigning an object called something else. So okay, so a couple of people are saying that they can't find, they're saying heart not found, it doesn't exist. So what you should do is if you go to RStudio Cloud, and what you should do before you run this document is click in this this down arrow and say clear pre-rendered output, and then go ahead and click run document and forward to the slide that we're on. It looks like we're on slide 22, and that should work again. All right. So so what we can do is we can create new objects. And so we just looked at heart target. So if we take that, put it here, we run it, and we have a bunch of zeros and ones, as we said. But what we can also do is we can assign that to an object called target. Let's say that we want to save this. So we run that, and nothing happens. There's no output, because all we did is we said, we're taking this, we're extracting target from heart, we're then assigning it to target. If we call target here, just like we did with our name example, and then we run, then what we can see is that this is the target variable that we just assigned. Okay. So let's again, just to show you the other example from before, when we had an object called name, we assigned it to a value 4, we ran the code and nothing happened. We then called name, and then we can run the code and we see the value of name. So it's conceptually equivalent. What we do here, is we run this, and then we take target, and we can run that, and then we can see it. All right, so hopefully everybody it looks like Allie's helping a handful of people get the slides to run. So again, this is a +DS session 1 RMD, and we're on slide 22. Okay, so we've got now objects. Objects are really important. They're going to be the way that we manipulate several things within the our environment. And let's see. We'll stop there, because what we're going to do now is much of the work that that I'm able to sort of share with you has this interactivity within the slides. However, most of your data science is not going to be done in a slide. It's going to be done in something called an integrated development environment. And that's what RStudio is. So what we'll do now moving forward is there still will be some opportunities to interact with the slides, but there will also be opportunities to then interact directly with the files within this within the project, this +DS project. And so if you're still having some problems getting it to run, that's not too much of a problem. Again, this really early part is just to introduce you to some of these concepts. So I'm going to pause here just for a minute to go to the chat boards and see there's a couple of questions. So let's see. I'm just looking if clear pre-renders. Okay, why would values from Here, let's go to here. So why would values from heart target change to negatives when put into the object target and then run? So why would they do that? All right, so if we go back to here, if we go here, the range, so target, I'll tell you a little bit more about this data set in just a moment, but this is a heart failure data set. And target is whether or not these patients have heart failure. It's not a very intuitive name. And this is a binary value at 0 or 1. This could also be true or false. So I don't know why this should be, I don't think that they have negative values here. These are really just whether or not, essentially, a binary. 0 is this person does not, oh, sorry, it's not heart failure, it's heart disease, does not have heart disease, and 1 is this person does. So let's see. Tidybiology, can you demonstrate how to clear a pre-rendered output? Sure. So if we come to here, you guys should be able to see my Tidybiology. So again, if I am in my Tidybiology 2020 workspace here, you should have a project. This project has a project called +DS, so you click on that. If you clicked on mine, it should make a new copy for you. If you clicked on that one time, then you should have your own copy. And if we come back here, I'm just showing mine. Here's everyone's. So what you might see is mine and then yours. So then click on yours. So you should have your own copy. If we go here, then it should look something like this and then something like this. So we have a console, terminal, jobs, a few different windows. Within this project, this is the top level directory of this project. Then this folder here is called code. So if you click on that folder, you've got a bunch of different markdown documents, these RMD files. Don't worry about those. I'll tell you about those in just a moment. But what you want to do is you want to go all the way down to the bottom where it's +ds session1.rmd. These are the session 1 slides. And then if you click on that, then it opens up. You can see that this file is now open. Before we click on Run Document, what we want to do is we want to then click on this down arrow and then click on Clear Pre-Rendered Output. And it says, are you sure you want to do this? And just say yes. And then click on Run Document. And when you scroll forward to the sides, heart should be available. So there's a weird caching error that we're still trying to figure out about when you first launch this. It will cache a bunch of information for you, which just means it stores all of it. And then when you leave and come back, it tries to find that old cache, but it can't, and so on. So just say clear that pre-recorded. Again, we're trying to use some new infrastructure, hopefully try to have this a little bit more interactive, but there's still some bugs that we're still squashing. So, okay, so maybe just one more question. When I run the target by itself, it shows positive ones like you showed. When using target, when then running the target object, they change to negative. So this is what one of the users said here. This is strange behavior, because if we go then, so what this user is saying is if we go here, here, target, run code. So if we go like, let's go like this. So this should look like this, okay? And then if we assign it to target, and then we say run code, now we have this object stored. But if we want to then call that object and see what that object looks like, we run this code, and we should see a bunch of zeros and ones. And then a couple of people are saying you're typing negative, two of those. Okay. Yep, make sure that maybe this is running the code. Okay. Akshay and Lindsay, you guys get a gold star. So it looks like, just make sure that you have one arrow here. So it's one little chevron and one dash to make one arrow. And hopefully that works. So we run that code, problem solved. All right, brilliant. Okay, so let's then go ahead and move into this concept of this integrated development environment. Okay, so One way to think about R, and the R is this language, a statistical programming language. A great analogy by the guys over at Modern Dive that make a fantastic statistical package is that R is like the engine. And again, when we interact and interface with R, it's just like this code chunk. Like we can run really anything within this this code chunk. This is a bit like a console. Oh, it looks familiar, like a terminal. All of these different words are going to describe this type of environment. And again, this is just totally empty. If we again go something like this and target, this is still here, we can see that this is going to then basically be available to us. Now, the thing is, this works just like the engine of a car works. But really what we want to do is when we drive a car, we don't want to interface with the engine directly. It's much more satisfying and much more efficient if we interface with the dashboard here. And this is the idea about this IDE. So different programming languages all have their different and their preferred IDEs, or their integrated development environments. And so one very popular one for the Python programming language is called Jupyter. And so if you've heard of a Jupyter Notebook or Jupyter Labs, they make this both local and cloud-based Jupyter Notebook. The Jupyter Notebook is an integrated development environment for the Python programming language. RStudio is an integrated development environment for the R programming language. It turns out that the RStudio can also run several different types of code, which is something that they are continuing to work on and develop. But this is going to be much more useful and much more friendly and helpful environment to do all of our programming in. Okay, so what we can do here is so RStudio really is a company. It's a nonprofit, recently turned B certified corporation, and so it's a nonprofit corporation that makes several different products. One of which is RStudio, which is a local installation. One of them is also this RStudio Cloud, which is what you guys are using here. All right, now what I would like you to do is to go to your RStudio environment, and I want to give you just a very quick introduction to what this looks like. So over here in the code folder, so again within this project, this top level project directory, we have a folder that's called code. And what I want you to do then is you can see that there's several different files here. One of them is called 01rdemo. So if you just click on that, you open it up, and really now what we have is this interface that I want to walk you through. All right, now this top left part here, this is going to be these R markdown documents. These R markdown documents we'll be spending a lot of time within, but this is just the very first introduction to it. So what you can see is that there's this concept where the R markdown document is going to intersperse text and code. And the codes we call code chunks, which is exactly what I was referring to earlier. So here we have some text, and then what we have here is a code chunk. And then what we have is some more text and some more code chunks. And so what we can do is we can then take some of these, this math here. So if we just take 10 times 10, if we do this, then we get this R is essentially a fancy calculator. It's a little bit like if we were looking at our code chunk here. If we take 10 times 10 and we run it, we get 100. So we can run in the console here. We can do all of our programming from the console. But what happens is it's much more convenient and much easier and more intuitive to run it in this R markdown document. So what we can do is we can then run this single line. So if we run this selected line, so what I did here is this run button will become very important for you. If you click on this green arrow here, it's going to run everything in this box. If you then drop down here, you can run the selected line. We get to 10 times 10 is 100. Go ahead and click on this green run all, and what will happen is it will run everything here. So we run 10 times 10, 1, 2, 3, 4, and so on. We can then take 10 times each of these things, these numbers, 1, 2, and 3, and that's here. So if we just go like this, we can see that. If we then assign 1, 2, and 3 to x, and then we take 10 times x, we get the same thing. I'm running a very simple shortcut on my Mac here. This is Command Enter. This is the shortcut to run a single line. You can come here, and you can see this is Command Enter. On your Windows machine, if you click here, you'll see what the shortcut is there. Now, if I run this one, I get an error. And we would see the error here, error in x times 10, non-numeric argument to binary operator. Okay, what does this mean? It's the very first error in R. So congratulations. You will see several of these. And what we can see is that we have a non-numeric argument. That's x here. So x is in quotes, and remember, quotes is not how we store objects. So what we want to do is we want to do something more like this, where we say 10 times x is here. If we do this last line, line 20, what we can see is that we cannot multiply a number by a letter, essentially. So, so this is the R Markdown document. We'll be spending a lot more time with this, but essentially what we can do when you run some of the R Markdown document, the console shrinks, but we can run everything in the console here that we can up here. It's just this is going to be able to save it. It's going to be able to intersperse text and so on. Okay, the last thing I want to show you basically on this brief introduction is this environment. So this environment will be important because this is where we're going to store objects. So what we have now is we have an object called x. And x is storing 3 numbers here, 1, 2, and 3. And we can see that if we go to our environment, we can see that we have something in our environment called x, and it's 1, 2, and 3. So below this last line, I want you guys to just make some space within this grayed out code chunk area. I want you to then assign another object. So again, I'll just type my name. You guys can type your name. Remember, no quotes because it's an object. And then what I want you to do is just assign it a number. So let's say lucky number 7. And then I'm going to run this single line. And what you can see is that now I have another object in my environment, the object I called Matt here. And this has a single number, and this is the number 7. If I would go like this, and I have another object called name. Now I have an object called name, and this holds a string. And this is, we'll talk about strings more later, but this is basically a word, and this word is Matt. So go ahead and you can assign a couple more objects to your to your environment here. This will be important because you'll want to keep track of exactly what we're doing. You can see that we do not, in this environment here, we do not have heart in our environment, but if you, which is this data set that we were using. But if you go back to the RMD now, which is this one, there's some code in here that will load heart. Don't worry about that for now. We'll load it a little bit later. But you'll be able to then track what's in your environment by just looking at this upper right-hand corner. And then on the lower right-hand side, what you'll see is then just your directory. So this is essentially your Explorer or Finder windows where you can navigate. The things that I always try to do is I always try to have a code folder or code directory, and this is where all my code lives. I also have a data folder. This is going to be, again, we've got a couple of different data sets in here. So those live in data. Media, this is actually for some of the presentations. I've got some different visualizations that I put in the slides. Those just live there. README files, that's for the GitHub repository. And then finally slides is where I put the PDFs. So this is the introduction now to the integrated developer environment. And so if you had to then envision using either just this console or using the console in R Markdown and the this environment list and the repository here, you could see that this is going to be much more sort of friendly and much more efficient for programming, which is why essentially very rarely would you interface with a programming language directly with the language itself. This is why you are going to have some sort of integrated development environment. Okay, so now we come back here. And what I want to do is I'm going to transition and spend a little bit more time with R Markdown. You'll have an exercise that will sort of walk you through an R Markdown document. But I'll just take a moment and turn to the chat boards again and see if anybody has any questions. It looks like Akshay is still trying to help some people and Ali as well, trying to help some people get online. But does anybody have any questions so far about some of the content in the presentation? Okay. So we'll go ahead and then talk a little bit more about, I keep talking about this R Markdown, these documents and so on. So what is this R Markdown document? Well, what I want you to do is I want you to go ahead and now, some of you are asking, is it going to be a problem if I don't have access to this, that, or whatever? Hopefully, if you don't have access to those little code chunk examples with heart, that's not a problem. Everyone should have access now to a file within the code directory that's called 02 RMD exercise. So what you should do now is navigate over to the code directory, and the 02 exercise, RMD, you want to click on this. All right, now what I'd like you to do is go ahead and take 5 minutes, and I'll put on a little countdown timer, and essentially read through this and work through it and follow the instructions and do what it says. All right, so I have a little 5-minute timer that I'm going to put on. I'm going to put on a little bit of a background coffee shop working music. So you guys can go ahead and just take a few minutes now. If you need a short break, go ahead and take that now, but we'll go ahead and we'll take 5 minutes and we'll work through this. I'll turn to the chat boards and make sure that no one is floundering and not able to follow along. All right, welcome back. So hopefully that gave you a sense of the R Markdown document. Go ahead and scream on um, the the chat board if you need a little bit more time. But the idea is really just to have this sense of code, text, and so on. We'll talk a lot more about these R Markdown documents, but really this is just the first introduction. So let's see here. Now, this R Markdown is what they call an authoring format for data science. And there's essentially three different elements. The elements are a code chunk, which is here. You then have some text before it. So the code goes in the code chunk. And then there's a code result below that. So when you guys ran a couple of those examples, you saw then the results come out right below that. So we're going to be spending a lot of time in these code chunks. And again, this little green play button is to run the code in this code chunk. All right. Now, who has any burning questions about these R Markdown documents, about how we intersperse code and text? Any major questions about that? Okay, then we'll just keep marching right along. All right, now, the power of R is that it's a functional programming language. So one function that we've already seen is round. Another function that you saw in the example was mean. You could take the mean, the average of some set of numbers. But it's interesting because there's literally thousands of different functions that exist for the R programming language in the R ecosystem. But the interesting thing is that these are not then all installed when you guys install R in your machine. Really, it's only a couple hundred of these. And this is called base R. And so base R is this base installation that has a certain set, you could think of like a skeletal set of functions that is enough to run R and do a lot of very powerful transformations. But when you start getting into different types of bespoke analyses, what you want are functions that allow you to do those analyses easier. So let's say I want to do some sophisticated statistical data transformation. Well, fortunately, I don't need to write a function from scratch to try to do that because there's an entire ecosystem out there of functions that likely has already accomplished what I want to accomplish. Okay, so how do we get access to those? Well, the way that we do that is by accessing packages. And so these packages contain functions, data sets, help pages, and so on that are grouped into a sort of collection that allows you to do a certain set of activities. And you can install these or not install these. At the very beginning of the course, I talked about how some of these functions are going to be or packages are going to be installed or not installed, and so on. And so these packages really are what allow us to do all of these very cool data science activities within the R programming language. Okay, so we've been talking about functions, but what exactly are functions, right? You've seen a couple of examples, but essentially what they are is the way to think about them is when we talked about R as a language, and I'm teaching you a new language today, well, these languages have verbs, and verbs are actions. So these functions are verbs that act on data. And the way that you can think about this is our function says do this, and that's the function, to that. And that's the thing that we do this thing to. We also then have this idea called an argument, or one of these optional arguments. And we would say do this to that, and the argument would be using these. And so what we can think about is a function is going to then perform an operation on some data or some object. So it's going to do this thing to that thing, and that thing is typically some type of object. Okay, and really it's these functions are the power of using R. All right, now packages contain functions, documentations, data, and so on. So here is an example of a function called dplyr, and dplyr is going to be one of the first packages that we'll be looking at with some very useful functions for data science. these main dplyr verbs, mutate, select, filter, summarize, and arrange, are ones that you will be seeing very soon here. And there's literally hundreds of different packages that allow us to make these transformations of data. Most packages are stored on something called CRAN. And CRAN is a central R repository that basically hosts these packages and has very tight and very strict requirements for the types of packages that can go on CRAN. So when you download something from CRAN, you're not guaranteed, but you have some strong indications, we'll say, that these are good packages that will be compatible, that won't break your R environment. And really the way that we think about these packages, and you can see literally hundreds, now thousands of packages, this is a cumulative a sum of the number of packages ever published on CRAN. You can think of them as these optional extensions. So we've got base R, and then we have packages that we can then use to get functions to do operations to our data. Okay, so how do we use packages? Well, there's two different things that you need to do. The first is we need to install them. And the way we do this is with a function called install packages. Fortunately, this is a very appropriately named function. And what we say is we want to install packages, and one package that we'll be talking about is the tidyverse. We do this installation one time per computer. And this is important because what it will do is it will then go to CRAN, typically, and it will take the information from CRAN and will install it onto your computer, and then there it lives. Okay, if you don't install a package, you will not be able to use it, which is why sometimes you will see in RStudio, if you get some code from somebody, let's say even from me, and RStudio then detects, you're using a function in this package, but you have not yet installed it. Would you like to? That's convenient, but essentially we need to install a package one time per computer. All right, so what is this tidyverse? Well, the tidyverse is what they describe is an opinionated collection of R packages that are designed for data science. And we'll be doing a lot with the tidyverse packages. And the fortunate thing is they all share an underlying design philosophy and grammar and data structure. These data tables and data frames that I told you about earlier, like this is the core thinking behind this collection of packages. And if we have our data in a certain way, then we can do so many different transformations of it. All right, so this is the tidyverse, and this is going to be our first introduction to it. Okay, so first pop quiz. The tidyverse contains several packages. These have very wild names: ggplot, dplyr, tidyr, reader, and so on. How would you install them? Well, I just told you we use the function install package. However, this would be kind of a pain because we would then have to do install packages, all this times through for all of these different packages. However, the tidyverse is really a sort of meta package. It's a shortcut for installing and loading several of these different components of the tidyverse. One of the questions that just popped up that I'll add is, do packages have versions? Yes, absolutely. And there's two different ways to update a package when it's updated. One is just to run the installed packages again. And if you have that package already on your installed, it will say, oh, you already have it installed. Would you like to update it? And you can say yes. There is another way to, within the RStudio environment, to update the packages that you want to. But yes, absolutely. When new versions of R come out, oftentimes packages need to be updated in order to not break. Okay, so we've got this shortcut for installing several of these packages, which is just install packages tidyverse. Okay. Now, using packages. So I said the first thing that you need to do is you need to install a package, and you do this one time per computer. But the other thing that you need to do is you need to load the package. You need to tell R that you are going to be using this package, this collection of functions in this session of R. Okay, so what that means here is that we need to, at the beginning of our code, we need to what's called load the libraries. We need to load these packages. And without doing that, then what happens is the R will then try to call the function that you, let's say, have in that package, and will say, I can't find that function, because that instance of R, that session of R, needs to use it. So you just use the function library and you call the package name, and everything then is available. All right, now the reason for doing this is because I have, let's say, 100 different packages on my computer, but I'm not using them every single time. And so it becomes much more efficient to only load the packages that I want to load, that I need those functions for. All right, now, so just a couple of the key ideas. Downloading a package isn't the same as using it. You have to run library followed by the package name in order to use it. So this is exactly what you do, and this is what we're going to do at the beginning of every single R markdown document, at the beginning of every single session. I'll also just take a moment to mention, oftentimes I'll say I'll load the tidyverse, and I'll be doing a bunch of data science and writing code chunks and text and so on, and then I get halfway down and I say, oh, I need another package. Well, what I could do is I could just say library package and then just keep going. But what I would encourage you to do is to go back up to the top in that very first code chunk, load the libraries that you need, and then go back and keep going. Try to keep all of your packages that you're loading all together. It will make your life much, much easier. Okay, so this command loads all the functions, as I said, and gets it ready for that session. Now, importantly, if you close R, you'll need to reload the packages within that with the function library if you need them again. And so this is important because if you are then doing some work, let's say on 2 different projects, and you have like one library that's open, you can actually use that library for another R markdown document, even though you don't call that sort of package within that document. And so then if you close that first one, close everything, come back the next day, if you didn't load it for that code, then you're just going to come up with an error again. These are really small errors, small problems to fix, but just things that you need to be aware of is that every time you use a package that you want to load in that session, use this library command. All right. Now, I told you that we want to use these packages right at the beginning of our document. Now, what we do is we have a special chunk, and we call this the setup chunk. And the setup chunk is always run once, and is run before anything else. And this is where I would encourage you to list your packages. So you can see in this sort of zoomed in picture here, we can see that we have a code chunk. This code chunk has a label. Chunk labels are optional. And what I'll just remind you of or mention is that the setup chunk is a very special label. It's handled differently than some of the other ones. But what that means is that you want to have a setup chunk. You label it setup right at the beginning, and then you say library tidyverse and library any other packages that you want to install. So this is the sort of practical way that you're going to do this. All right, now what I want you to do is I want you now to go back to that R markdown exercise, that 02 R markdown exercise that you just finished. Now, if you, so it should look like this. If you got all the way to the bottom and you tried to run this code and it didn't work, then what you want, so the reason that it didn't work is because it doesn't know what this function is, all right? Now, what I want you to do is I want you to go, just like these instructions say, is I want you to go to the top of this exercise, and I want you to make a setup chunk that looks exactly like this. I want you to insert a chunk, and then I want you to type setup, and I want you to then say library, parentheses, tidyverse, and then I want you to run it, okay? Now, if you come back here, say, okay, well, I'm not really sure how to make a setup chunk. Well, I'll take a moment and show you here. So you should have something that looks like this, and you can insert a code chunk by just clicking insert, okay? And then I'll do this along with you. Oh. Whoa. My cursor, I made this bigger for you guys, so my cursor is a little bit crazy. This is setup. Okay, and now library, tidyverse. And then I hit run. Okay, now it's going to load a bunch of functions. And one of the functions it loads is this one here. And then I can run that. And I can see that, don't worry about what this code means right now, but this is a plot. And this plot, if you still have a pound sign on the front of it, delete that to uncomment it, just like we were talking about earlier in this R markdown document about commenting and uncommenting code. So uncomment this code, and then go ahead and run this here, and you should be able to make a plot. All right, so go ahead and give a little thumbs up if you got the plot, and ask for help on the chat boards if it's not working. All right, Jason, I'll add this one. Jason says, I missed something. When is the install packages tidyverse added? Great question. I've already done this for you. So all of you should have tidyverse already installed within your environment. Now, if you come up here and you type tidyverse, library tidyverse, and click run, and it doesn't run, it will say you don't have this installed. It will then prompt you to install it. But I did this for you, just trying to make your life easy. Most of the packages that we need for this course, I've installed for you already. So all of these should be taken care of, but you still need to call these packages and to basically load them into your session by writing library tidyverse. Okay, good. I'm seeing the thumbs up pile in. That's good. All right, you guys are making plots already. That's good. All right, this is a simple plot here. We've got our heart data set. Again, I'll tell you a little bit more about this in just a minute, but this is a heart data set, and what we're comparing is a patient ID, and we're just looking at the range of cholesterol values, serum cholesterol values of these patients in this heart data set. So, all right, you guys are getting there. That's good. If you have any questions, all right, Marie even gave a strong arm. Nice job. Keep it up. Okay, we've got the horns of rock. Nice, Sean. Okay, so the tidyverse. The tidyverse is one suite of tools for data science, and really I talked about this collection of packages because data science really can be defined by a couple of different activities. The first thing that we need to do, and that's actually displayed on this picture here. So what we first need to do is we need to import. We need to get data into an environment. In this case, it's the RStudio. We then have this step, it's called tidy, which is going to standardize the way that that data is formed and shaped, what it looks like, get it all. This is also called cleaning, so we can tidy the data or clean the data. And then this concept of exploratory data analysis is going to be to really take your data, to transform it, to visualize it, perhaps even model it with some statistical models, to retransform it, to ask a question, to explore, that leads to another question, to explore more, and finally to basically what some people colloquially describe as rolling around in your data and really letting the questions emerge. And this is where this domain expertise or the substantive expertise comes in data science. When you have a data set, and in this case it would be a healthcare data set, you have a sense of what cholesterol values mean. You have a sense of what is expected and what's unexpected and so on. And you basically spend some time with the data. Any good computer scientist, data scientist, biostatistician, or bioinformatics type person will tell you, you have to spend time with your data. And that's exactly what this exploratory data analysis looks like. In fact, the concept of exploratory data analysis comes from the field of statistics. The final step in this exploratory data analysis is to communicate your findings here. And so the nice thing about the tidyverse and this collection of packages is they have a package for this step and this step and this step. Basically, every step along the way, they have a collection of packages, and they being an army of open source programmers have developed these packages that make it, like I was telling you earlier, easier than it's ever been before to do data science. All right, now the tidyverse basic principles. So I'm going to be teaching you a lot of these tidyverse packages and some of these basic principles. And this is really going to be the crux of what we'll be spending our time with today and tomorrow. So we'll be diving more into some of these key functions, but I want to show you some of them here. So in this import step, there's a package called reader, and reader has several functions. Two of the common ones that we use are read_CSV. As you can predict, this is going to read a CSV file or import a CSV file into RStudio. Also read delim, which is a different type of delimiter file if you have a tab separated or different types of delimiters to separate your data. Again, several more types of data. You can read Excel, you can read SAS files, you can read, there's formats for Python data frames you can also read into R. So however your data are, you can get this into the RStudio and the R programming environment. And then this tidy and transformation, one of the most powerful packages in the entire tidyverse is called dplyr, and that's here. And this is going to be to really this idea of rolling around in your data. So this is going to allow us to very easily add new variables, perform some math on variables, select, filter, and so on, look for relationships. The reason that people sort of have flocked to the tidyverse for data science is really the powerful visualization tools. And so there's a package called ggplot. We'll be touching on that at the end of the day today, and then much of the day tomorrow is going to be on data visualization. We'll be using the package ggplot. And finally, we won't spend much time on modeling. There's a series of packages. One is called Broom here, which is going to then model. And again, this is sort of the introductory early data science. We're not going to be getting into statistics. We just don't have the time. But there's really some fantastic tools that allow the tidyverse to interface with several well-established statistical packages within the R ecosystem. Okay, so one of the most important things, though, to share with you about the R ecosystem is actually a concept that was taken from another package, which is called Magritte. So René Magritte is was a French artist who has a very famous painting, Ceci n'est pas une pipe. I apologize for the French speakers in the audience, but essentially this is a famous painting that says, "This is not a pipe." The sort of tongue-in-cheek irony is that, yes, it's a pipe, but it's not a pipe because it's a picture of a pipe. And René, the artist, would say you cannot smoke it, you cannot stuff it, etc., etc. So this has been, it's a sort of fun piece of art, but this concept of a pipe has been co-opted from some other programming languages. Originally was involved in this, or sort of described in this Magritte package, where this symbol here of a pipe is sort of leveraged heavily in the tidyverse. And so this concept is a pipe is a way to connect a couple of different functions. And what we will be doing is we will be connecting different functions and stringing these functions together. And we'll be doing this by using this operation or this operator, which we can then describe or we can say as and then. Okay, so what is this concept of a pipe? The pipe is a sequence of functions that are sequentially applied, and the sequence is going to be important. So here's the simplest example that I could come up with. All right, we start in the morning, we wake up. What do we wake up? Self. Again, we have an action and it does it to something. And then we put on, here, we put on close. When we see this operator, again, we want to say to ourselves, or say out loud if no one else is going to be judging too heavily, we want to say and then. So we will do it together. Wake up self, and then, put on clothes, and then, eat breakfast, and then go to work. So here are 4 different actions. These are 4 different verbs, 4 different activities. In this case, we wrote them as 4 different functions that we string together sequentially. We would not want to go to work before we put on clothes, for example. All right. Now, the alternative way to write this, and this is completely valid, is what's called nested code. And this nested code starts on the inside and then works out. So we wake up self, and then we put on clothes, and then we eat breakfast, and then we go to work. All right, now this is arguably a more efficient way to write the code. I have 1 line instead of 4 lines. And so if we can reduce the amount of code that we're writing, that would seem to be a good activity. Except what we lose with efficiency is also interpretation. So if we look at this first sort of a piped code, we can read easily. We wake up, we put on clothes, we eat breakfast, and we go to work. With this other one, it's not as intuitive. We could say we go, eat, put on, wake up, self, close, breakfast, to work. So this first example here, and this concept of the pipe, again, is heavily used in the tidyverse. And this is what I want to sort of impart on you, is this concept of being able to sequentially take data and then transform it, and then do this, and then do this. And when we do that, what it does is it allows people to then look at our code and understand exactly what we did in the easiest way possible. Okay, so pop quiz number 2. So we've got the pipe. We'll say, what does this code do? All right, so we wake up, self, put on clothes, eat breakfast, FMK, and then go to work. So let's go ahead and light up the chat board. Any guesses what FMK is? I'll give you guys a second. I should have put some Jeopardy music on here. Maybe I'll do that for the next one. Any guesses? Akshay and Ali, no guessing. Nothing. No bold guesses? So the reason that I put this in here is because on one hand, it doesn't really matter. It doesn't really matter what FMK is because you can still understand generally what does the code do. Well, the code starts with waking up. I understand most of what happens, and then the end, feed my kids. That's a really good guess. I like that one. So yeah, I like that. So the thing is though that find my car, close, Deborah. Okay. We're getting closer. Find my, so Deborah actually almost nailed it. Find my what? There are 2. Okay, so find my kids. Nick nailed it. All right, good job. So it's too bad that feed my kitten. Okay, no. So I intended it to be find my keys. All right, but the point of including this is that you don't need to understand exactly what the code does. Every single line. In fact, as young data scientists who are just trying to figure out this crazy field, what you will do is you will say, well, what is, I can kind of understand what's going on, but I don't understand this line. So, what's this about? So we wake up, we put on clothes, we eat breakfast, we find my keys, and then we go to work. All right. So just remember that most of the code that you read, you're not going to understand every single piece of it, and that's okay. We don't need to, just like learning a new language, we don't need to understand every single word while we are learning. All right, now pop quiz number 2. So this is very similar code, but we have one separate thing in here, one addition. So what does this code do? We would say that this code does essentially the same thing, but what we can do is we can save this. We can save this because it's a morning routine, and we can then take all of these operations and basically string all of these or stitch these together, and we save this as morning routine. So again, we can take this line of code, this sequentially applied, and we can save then the output of this. All right, now last one. Now we can say, what does this code do? If we read it together, we would say we take the heart data frame, which I haven't told you anything about yet, and then we select age and sex, and then we group by sex, and then we summarize mean age. So we can also, we can take this and we can put it in here, and we can play with it a little bit and see what happens. So when we do this, what we find is that you guys can barely see that. Let me get rid of these 2 lines here. What we can see is that is that a little better? A little better. Is that it takes some information from heart, it selects some variables out of it, and this group by, I haven't told you anything about any of these functions yet. We will be working on these functions, but this really is going to be an intuitive way. Really, I highlight this complicated example that I haven't told you anything about yet, because it's a way to then be to have some intuition about what's going on. So we we take an object and then we select it, and then we group by one of the variables, and then we summarize. And so if you want, you guys can go ahead and basically play with this code a little bit. So if we take heart and then we select just age and sex, what we see is something like this. And then if you want to group by, or and then if you want to summarize. So go ahead and play with this a little bit. The code should be there for you to play with. But again, the point really isn't here to know exactly what each of these steps is doing. It's really to get like this sense, and that's what we're trying to teach you with this pipe is to be able to string these different functions together. Okay, now a couple of things that I want to mention at this point. So writing code is not like drawing an owl, right? So this is sort of a funny meme that circulated sort of around the internet a few years ago, right? Because there's a very simple sort of example how to draw an owl, draw some circles, draw the rest of the owl, right? So writing code is not like drawing an owl, especially when we write code in terms of the pipe. Because what we want to do is we want to think more of writing code like this, like it's a stepwise process. So if we were then to think about building this Lego house, we would say, first we lay down the green base plate, and then we build some walls, and then we build a little bit more, and then, and so on. And finally you get to, and then we put on the roof, and it's a house. Okay, so this is really, again, nailing this idea of the pipe and really trying to show you, like, we have something called the pipe. It strings these functions together. And this is going to be the way that we really think about writing code. Okay, so we're now going to spend the next half an hour really getting into the data, getting into some of these functions, getting into some of the examples of getting our hands on this code that I've just told you a couple of times we can play with. So just take a moment, ask you guys if there's any questions. Some of you still say the heart object's not found. Don't worry about that. We're going to be able to transition to the our markdown documents within this. So you can try to, again, if it's not found, you can then come here. Again, just try this step, clear pre-rendered output. Okay, so any other burning questions? Akshay is still around to help you all. I'll sort of share any questions that you guys have with everyone else if there are any. But if not, then we'll sort of get to know our data a little bit. Okay, so I keep talking about this heart data set. So this is going to be the primary data set that we'll use for the rest of the class today and for tomorrow. So what is this? It's a data set that's a heart disease data set. It's called heart, cleverly named. This data set dates from 1988, and it actually consists of the integration of 4 different databases. One from the Cleveland Clinic, one from Hungary, Switzerland, and then a famous data set that's called Long Beach V. The complete data set has 76 different attributes across several different parameters. And most of the use of this data set has been trying to use different parameters to predict whether or not a person has or will develop heart disease. And this is that target prediction that we mentioned earlier. However, what we'll be focusing on is a subset of 14 different attributes that we're going to use for this class. Okay, so now I said one of the most important things is going to be to get to know your data. So we want to inspect our data frame. So we have something that's called heart here. Now, if some of you are still, let's try this. If some of you are still having a problem accessing heart, what I want you to do is go to, let's see, to code, and let's go to RMD, let's see. What you can do is if you open up 04 ggplot, this is only if you're having problems accessing heart within the slides. And what I want you to do is go to line 11, okay? Or actually what you can do is just play this entire code chunk or run line 11, okay? And this is gonna load, so if I go like this, it's gonna load heart into your data set. And what you can do is you can follow along in the console down here. All right, now, if heart is available, what you can do is the first thing we want to do is we want to inspect our data frame. So what does that look like? Well, first we want to see how big it is, what size it is. So we can use a function called dim, which gets the dimensions. So if we say dim heart, and then we run our code by hitting run code, then we should see that we have 1,025 rows and 15 columns. I told you on the last slide here that there's 14 different attributes. That's true. We added, for the purpose of this class, we added another line that's a patient ID. This is a completely made up. This is basically 1 through 1,025. You can see here, just for teaching purposes later on. So there are 14 different attributes plus 1 patient ID. Okay, so you can enter that here. So this is the first thing that you would do. You can get the dimensions. How big is the data set that I'm looking at? If this is going to be 100,000 by 100,000, that's going to mean something very different than if it's 1,000 by 15. Okay, now, while dim is informative, it doesn't tell us too much about the variables within it. So one of my favorite functions to use is glimpse. We can get a glimpse into the data by using a function called glimpse. And if we do glimpse heart, and we then run this, what we can see is a lot more information. So it tells us the number of rows, it tells us the number of columns, and then it tells us the name of each column. This is going to be important because we want to then access these names. These are called variables also. We want to access these variables within our programming. So knowing what these are will be important. We haven't talked much about the different types of data, but this tells us what type of data this data is. So this is a character, this is an integer. So we'll talk more about the different types of data within R, but this is going to be informative. And then finally, what glimpse does is it lists the first handful of values. And so like here, these are the cholesterol values. Here, we have different values for sex, different values for age, and so on. So I have several examples within the R Markdown documents that you guys will work through that will ask you guys to take a glimpse into the data to remind you guys to look at your data so you know what we want to plot. So for example, we know that cholesterol is called CHOL instead of spelling out the entire word cholesterol. So if we want to access any of these variables, we need to match what this variable is called exactly. All right, now, basic data types in R. So there are different data types. So we've got a character. I've told you a little bit about these. This is like the example from very early on. We also have numeric. So this is how R stores numbers. So again, these are, when I was talking about the values earlier, this is what I was talking about with R has different values, and then we went on to objects and so on. Well, the different data types are the different values, and so this is then basically what your value could be. So we've got something called a character, and we've got something called a numeric. We also have an integer. An integer is slightly different than a numeric. You don't have to worry about the differences. And so you can think of both of these as numbers. We also have a logical. This is a computer programming idea. This is called a Boolean, where we have only one of two values. It can be true or it can be false, and that's it. We also have some complex numbers in R. You don't need to worry about these. You won't see them very often. We also have something called raw. You won't see these very often. Two other things just to mention. We have a data type called double. For the purposes of this class, you can think of this as the same as a numeric. And then finally, we have something called a factor. We won't get into factors too much in this class, but you can. What a factor is, or what you can think of a factor as, it's a collection of ordered variables. And so these are character variables that have some sort of order to them. So for example, if you have months, months have a factor because factors have an order. You can also have some unordered factors. Of course, there's going to be exceptions to everything that I say, but factors will become useful when it comes to plotting. Okay, so these are the basic data types in R, and what we can do then is now we can use some of these functions to look a little bit more into some of these. So, all right, so in addition to the glimpse function, you can use class, and class will determine the data type of a specific column. So glimpse gave us the overview of the entire data frame. Class tells us something about a very specific variable. So in this case, if we take class and then we run heart on it, what we can do or the sex variable, we can see that this is a character. And so we can then do this also, let's say for age, we can do the same thing, run the code, we see this is numeric. So you can go ahead and try a couple of these if you would like. This is really just to get a sense of what type of variable it is. This will become important because especially when we get to plotting, because we can't plot numerics and character vectors exactly the same way. So let's see. Sanjay says error when using glimpse. Okay, so if you're using glimpse, just make sure that glimpse, let's see, has no spaces, no nothing in between. Basically, it's just heart. So we could also, I told you, you could come down to here, and we can, we see that heart is in our GLIMPSE, heart. We can run the same thing here. And so you can run all of these commands in the console if that's going to be more useful for you. Okay, so all right, so now we can start thinking about, again, sort of reintroducing this pipe. So we change some of these commands and some of these strings together. So now when we look back at what was a little bit unfamiliar before, we can start to understand what it means. So we take heart, which is this data set that we know a little bit about. We then select two of the variables, sex and age, and then we can filter sex for males only. And then, because each time we see this, we say and then, head. So head is a function that's going to print out just a small subset, that basically the top, in this case, 6 rows. I put head in a lot of these columns just because it will print out a little bit easier on the slides. But essentially what we're doing is we're selecting 2 columns and then filtering one of these columns, the sex column, for only males, and then we print it out here. So you can then, again, start to get some intuition in the sense of how this, this code piping works together. So we take our data set and then pipe it into select. We'll talk a little bit more select and a little bit more about filter in a few slides. But you can start to see exactly what's going on now. So this head function lists, as I said, only the top end results, which is convenient for us. All right. Now, so again, I want to sort of reiterate this. When you see this pipe, think and then, and then, and then. All right. Of course, the alternative is possible. You can filter, select your, this is heart, sex, age, sex equals male, and so on. This is the nested code. It works perfectly well, you know, but it's more difficult to read and so on. All right. In the last part of the class today, what we're going to do now is we're going to start manipulating the data. I want to take time now and show you some of these functions that will then allow you to manipulate the data and to really tell you what does select do, what does filter do, what do some of these dplyr verbs do. Before we do that, I want to then ask if there's any questions. Also then just see if there's anything on the chat board that needs to be addressed, anything that we can light up and share with everybody. Go ahead and let me know now. Okay, we'll keep going. So manipulating your data. What we're going to do is we're going to spend some time now with this package called dplyr. And dplyr is going to have a suite of functions that allows us to manipulate our data, to select some data, to filter data, to basically do this activity called exploratory data analysis. All right, some of the things that we can do is we can select different rows and columns, like I said. We can create new columns or new variables. We can then also obtain some very simple summary statistics on individual groups within our data. So dplyr has essentially 6 main functions that we'll be going over. And we'll sort of take these one at a time. All right, now a lot of these are intuitive, so I will spend a little bit of time on them, but because of the intuition of these, we'll essentially march right through these. If you have questions or if you want me to slow down, just again, let me know on the chat boards. And we'll address them. So Lindsay had a quick question. Can you quickly remind us use of the $sign? So the $sign isn't a function. So the $sign is here. So you can actually see, Lindsay, let me just go like this to share what she asked. So what you can see here is that the $sign sits in front of the, when we glimpse of the data. So the $sign is a way to access some of these variables. Now, we won't use the $sign a lot. The $sign is a base R convention. We won't use that a lot in the tidyverse. We will if we need to pull out a very specific, like if we want to pull out age. So for example, if we take heart and then we go age, what that's going to do is it's going to pull out all of the ages of all of the people. And again, if we go age, heart, age, we now have an object called age, and we can look at it, and it's over here. So it's a way to access some of the variables within the data frame. So we have other ways to access variables in data frames, and that's actually a great segue to these dplyr functions. So I just said that we could use heart $sign age in order to find a variable, but we can also use select. All right, so select is where we want to basically select some of the columns. We have 14 columns and a patient ID column in this data set, but we might not want all of them. So if we want heart and then select sex age, what we see is, you guys can do this again, either here or in the console. And when we do that, what we see is, again, this is intentionally repetitive to really try to teach you guys some of these key concepts. So now we can see and really know that select is going to select specific columns. So if we take out age and we just select sex, what we get is just one. So if we take out this head part, what we can see is that we get one column and 1,025 rows. If we go like this, heart, sex, and we run both of these, what we do get is essentially the same thing. We get 1,025 values, just like we get 1,025 values there. All right, so we can also select things except values. And we do this by putting the minus sign in front of our variable here. So if we say heart select everything except the sex variable, and then we pipe it, we can then take this and we put it in here and we run the code. We can see that we get all of the columns. Instead of 15 columns now, we only have 14. If we want to get rid of age also, we can do the same thing. Now we have 13 and so on. If we take the minus signs out, we can see now we have 2. Right? So this is a way to select columns or select not columns. So the important thing is there's actually several different select modifiers to allow you to give you some tools to select the columns that you want. Saying the column name is the simplest, especially when it's a small data frame like this. Okay, so we can then also select columns in between. So if we come here and we take a glimpse of heart again, and we run this, we can see that if we want to select age to sex, it's going to give us 2. So let's see if that's right. So what did this say? This said heart, and then select sex, age, and run that. And so that's giving us sex and age. If we want to then go like patient ID to age, it gives us everything. Let's go. It gives us everything in between it. Okay, so it's patient ID, age, sex, and it gives us everything in between. So this is used for a range of columns to return the columns in between that. So again, it's just there's a lot of different ways that we can select the columns that we want. But if we have highly complicated data sets that we really want to focus on specific elements, this is the way to do it. Okay. Now let's get to filter. So select is all about columns. Filter is all about rows. So the filter verb is going to evaluate whether or not the row meets a certain criteria. It's a logical statement. It's, does this meet this criteria? And if yes, I will include it. If no, I will exclude it. And it gets chosen or filtered out. All other rows are discarded. And so the way that this works, let's first start with categorical data. All right, so now we have got this sex column, and this is going to have male and female. We can say filter. You've seen this example before. Sex equals male. When we do this and we type it into our code here, we can then only filter the males. So what's happening here is, recall that on the last slide I just showed you, it's going to evaluate a logical a statement. And in this case, we need two equal signs. We say, does sex equal male? If true, it's included. If false, then it's excluded. And then we just pipe the top three. So, so this is how we can filter categorical data. But we can also do this, and it's a little bit more intuitive if we do this on numeric data. So for example, let's say we want to choose only the ages above a certain value. So 53 is a magical number for some reason, and we can say what we want to do is we want to then look at only the patients in this data set that have, oh, that was the cut and paste from the last one. Okay, let's go filter. Age is bigger than 53. So again, it's going to evaluate this logical, and it's going to say only, it turns out that there's only 15 people in this, let's go like this. So there's 602 people. It's showing all 15 variables. So there's 602 people in this data set that are older than 53. Let's say that's older than 70. How many people? There's 20. So 20 people. And we can then see how many over 80, right? So you can do things like this. And there aren't any. All right, so good question that came in. Can you do OR filters, or is there a function specifically for that? So yes, you can. And actually, that's, I think, going to be on the next slide. So you can do multiple conditions. So we'll first start with AND operators, so AND conditions. So we want to say heart, and then filter sex male, and then filter age greater than 53. Okay, so this is the most verbose way to do it. We start out with that example just to show you something that's intuitive. We get only the males that are older than 53, and it's only showing 3. If we get rid of this column here, we then, let's see, oh, I think that went back, yeah. So if we go like, oh, let's just do this here. We'll get rid of this head, and we can say in this data set, there's 399 males that are over the age of 53. All right, so that's how the most verbose way that you type that. Now, you can then also do something like this, where you say filter sex male, comma, age greater than 53. So this would be the same as an AND operator. So heart, let's just go like this for simplicity. Okay, so if we run that code, it should look the same as this code, which is going to be, yeah, so the males that are over age of 53 is going to be taking this and doing that. So for those of you just doing it quickly, we showed you can do it this way. You can also say this AND operator. An OR operator in R should look like this. And what we have is, are you male or are you over the age of 53? So this is going to be all males plus the women that are over 53, and this is 916. So that's how you do the OR operator. Okay. We'll give you guys some resources to learn more in depth. Like that's a great question. How do you filter in dplyr for two different OR variables? And we'll point you to some of those resources towards the end. I'm trying to get through this material. You can see we don't have too many slides left. Okay, so there's one question. Akshay got it. So how do you filter the age between this and Akshay nailed it with you can filter over the age of 60 and like that. Okay, so what character is that? I'm not sure what that means. Anyhow, we'll move on to the next one. Maybe Akshay, you can follow up about which character is which. So arrange. Arrange is another dplyr verb. We can then take an arrange, and it basically puts variables or puts the observations, the rows in ascending order from smallest to largest. So what we want to do is, let's say we have heart. Let's say we do a filter, but then we want to arrange it. We can then go like this. I'll leave that out. And we run the code, and what we can see is we're arranging on age, so it goes youngest, and there's some 29-year-old males in here, 34-year-old females, and up it goes. All right. Now, we can also do this in descending order. And the descending order, we basically add another function inside the arrange function, which is descend. So it's the exact same concept, exact same way. If we do this, and I'm just going to show you the whole thing, we can see that the 77-year-old male is going to be the oldest in this data set. So we do arrange, and then we put a descend in it, and then we put the variable that we want. Okay, so that's arrange. Mutate. Mutate's going to be a really important one. This is a powerful one. Mutate is going to be the way that we create a new column. Okay, so if we want to take our heart data set and we want a new column, and we're going to say that new column is going to be the square root of the age, because that's going to be a really important sort of calculation for us to do. What we would do is we put this, this function inside of mutate. So the way that we do it is it's going to then take heart and then mutate. And mutate is going to expect the name of a new column. In this case, it's just new column. And then it's going to expect then equals, what does new column equal? It's going to then be a function, or it's going to be some value that is expecting to populate that new column. All right, now, if we do that, let's go ahead and you guys can try that in the code chunk here. We can then just say heart and then mutate new column, square root of the age. And so we can see that, and actually then let's go and then select, let's go patient ID and new call. So what happened is we just did this operation, and you can see a bunch of your variables here, but we don't see new column. Well, that's a problem. Where did it go? Well, if you look down here, there's 7 more variables and it lists them. And one of the variables is new column. So if we then just take a select and pipe it in here and we run that, then what happens is we get patient ID and new column. It was there the whole time. It was just hard to see. So mutate is the way that we add a new column. We can then call this square root of age, and we run this code. And again, here's our new column down below. All right. Now, one of the questions that came up that Akshay had an important answer to was about getting rid of the last pipe at the end. So what happens is if you don't get rid of this last pipe here, what's going to happen is R is going to be waiting for something. It's going to say, I have a data set, and then I mutate, and then it just waits. So make sure that you don't have this sort of hanging and then at the end. Okay, now a pair of probably the most powerful functions within dplyr is the summarize. The first of 2 is called the summarize verb. And so summarize is I'm going to then aggregate the values of your data frame, and then it's going to perform a calculation on it. So the simplest example here is going to be to calculate the mean age. So the way that we do that is we look at something like this. We take heart, and then we're going to summarize. And what it's expecting is expecting a function and then a variable. So we wrap this function and variable within the summarize. And this isn't going to make a new column. A new column is going to make a new column of a type of data. Here what it's doing is it's taking that entire column, and it is going to then collapse that down into a single value. and it makes a new data frame in doing that. So if we take this function here, what we can do is we can see that the mean age of this data set is 54.4 years. So this now is going to, again, it's a brand new data frame. It's going to be, we can save it. We could save this as an object. We could say this is mean age and go like this. And we run this code. It's now an object. If we want to call that object, we go like this. And we can see that this is a new data frame. It's a new tibble. It's very small. It's 1 by 1. And it has a single value. So again, this is going to collapse. This is summarizing. This is giving you some, you can think of like summary statistics of your data based on what you call here. All right, now, the reason that this is so powerful is because it's got a pair of functions. It's got a partner here that makes it a powerful combination. So what happens is we can do the exact same heart summarize mean age, but we can throw a function in called group by. And group by is going to summarize, allow us to summarize by groups. So if we take heart and we run group by, and then we summarize by age, if we run this, what we end up now with is the last function was summarized. So we would expect a new data frame. We expect a new summary statistic here. And when we run that, we do, but instead of a 1 by 1, we now get a 2 by 2. Because what happens is we collapsed heart, but before we collapsed it by just doing a summary, we grouped it. So what you can do is you can then start to envision how if we group by different variables, we can then start performing different summary statistics on the different variables. Like, what's the mean age based on sex? What's the mean age based on, or the cholesterol based on sex? Or what's it, you know, there's so many different directions that we could go here. And this is, again, where the most powerful combination of this pair of functions lies. Okay, so remember this pair. All right, well, we're just about to the end of our time, and I have a few more slides here. The final slides I'm going to show you is how to save a data set and then a couple of resources. So if you just have another minute, hang around. I want to show you that you can save the output just like an object using the operator. We've done this plenty of times, so I don't need to belabor this point. But if we go like this and then heart new, so we take all of this code and then we call heart new, what we get is the exact same thing. And so we save that, we can then store it for later. The other thing I'll mention is there's a function that's called write CSV. So let's say that, I know it's difficult to imagine, but let's say we now have some colleagues who are not very proficient in R, and we want to share some analyses with them. We can also take our data frame or our tibble and we can export it into a CSV. And this is through the very intuitive write CSV. So we would take our heart new function, we would write a CSV, and we can save it for later and share it with our Excel sort of bound colleagues. All right, now the thing that I'm going to sort of leave you with is going to be some homework. So there is a data science workflow that will be homework if you choose to do it. We will be able to go over this tomorrow, or if you want, you can show up a little bit early tomorrow and ask about this. But if you go to the code directory and you open up the RMD 3, this is going to be here. This is going to be a data science workflow. So start at the top, put your name, put the date, and start working through this and see how it goes. We'll be, like I said, we can talk about this tomorrow, but this will be something that you guys can do sort of in your spare time tonight to practice some of the concepts that you learned. So the last thing that I want to leave you with are some resources. So if you go to Google and you take your favorite package and you Google like dplyr cheat sheet, what you'll find are the dplyr cheat sheets. There's several cheat sheets for the different packages that we went over today. Also within RStudio Cloud, on the left-hand side here, there's this menu that you can see. Cheat sheets is one of the options. So if you click on that option, you actually get over to the cheat sheets where you can then go down and look. And so, for example, let's take a look at the dplyr one. Data transformation with dplyr. You could say download. So allow. I think you guys, I don't think you'll be able to see this. Anyhow, you can then basically look at the different options of the functions that are allowable. Okay, so Cheat sheets, totally awesome. Package function help. If you have a question about a specific function, you can go into the console and type question mark in the name of the function. So if we go here, let's come back here, and we type question mark mean. What'll happen is over in this help side, the help page for mean will come up. This is the arithmetic mean, and it will tell you all about it. You can then also search here, like we looked at a verb mutate. And it's like, what was mutate all about again? So you type in mutate, you can also search over here, and it gives you all of this information. There's also something that are called vignettes, where you can sometimes find a vignette about a function. Okay, so one way to do that, like the dplyr vignette, you can just run this. Within RStudio Cloud, sometimes it doesn't quite find the website, but again, just go to Google and you can then find links to some of these different vignettes. The final two resources I'll mention, one is called Stack Overflow. If you have an error in R and you don't know what it's about, essentially what you do is you take that error, you copy and paste it into Google, and that will lead you to a site that's called Stack Overflow. And Stack Overflow is sort of where developers learn, share, and build code. So then if you just type in, there's a tag here for all things R. These are questions and people vote them up and down, but essentially it's a resource that allows you to figure out, like, how do I filter or and dplyr. Let's see if that works. Row-wise filtering and dplyr, subsetting, how to use approximate. So a lot of different very specific questions that I see here, but that could be a resource for you. And the last is a book that is online and free, which is called R for Data Science. And this is going to be the sort of manual for most things R for Data Science, written by Hadley Wickham and Garrett Grumland. So this is also another great resource. Okay. With that, what I need to do is I need to acknowledge Ali and Akshay, both for manning the chat boards right now, but also for helping develop a lot of this course content and teaching it with me. The inspiration, ideas, packages, and code comes from an amazing community. And I'd like to thank you for your attention, questions, and so on. And what I'll do is we'll hang out just for a few minutes if you guys have another couple of questions. But otherwise, we'll see you tomorrow at 4:30, and we'll pick up right where we left off. We'll go over the homework and then take a look at data visualization. So thank you. All right.